So today we're going to take a piecewise graph and try and come up with its equation. Yes. So the first thing that might be helpful is to figure out where my graph splits. Where are these changes happening? Okay, so actually I'm not even sure that I want to do, yeah, let's just start with this one's fine. So make sure you're looking at the same one I'm looking at. Okay, so I do have something, this doesn't go off to infinity, right? So there is a dot there. So I do have something happening at -3. So this graph is only going to exist between -3 and 0. Notice how both ends have closed dots. So when I go to set up my boundaries, I need to tell it or equal to, right? Because I have closed dots. So this first one, I don't know what its equation is, but I know it's going to exist when x is greater than or equal to -3 and less than or equal to 0. Does everybody agree with that? Do you see where I'm coming up with those numbers, with these values? Okay. Then I'll work on my middle one. The middle one is only existing between x values of 0 and 1. Do you see that? Only from 0, when x is equal to 0, to when x is 1. What am I going to put? Do I put the bar underneath it or not for the 0? No, because it's open. So that one, that side just looks like that. But when I hit 1, do I want to put the bar here? Yes, I do, because that one's closed. So this guy only exists between 0 and 1. And then this guy, I know he doesn't have an arrow in the end, but when it goes all the way to the edge like that, we're just going to assume that that's an arrow. So if you want to add one in. This third branch, if you will, exists where? When x is greater than 1. What? Oh, sure. So now I have my boundaries set up for all three. So the only thing that I have to do now is figure out what their equation is. How do you figure out the equation? Yeah, I need the slope and I need the... Yes, so if I want to do this in slope-intercept form, which I do, right, I need the slope and the y-intercept. So for this first one, I have those things. I know it's hitting the y-axis at 0, and I can also pretty easily tell the slope is 1/3, right? From one dot to the other, I'm going up 1/3. So this equation, wouldn't it be y equals 1/3 x? Yeah, so I already have the y here as f of x, so I'll just write that in as 1/3 x. All right, that was easy enough. See if you can come up with the equation for the second one, this guy. Okay, who's got it? Aiden, go ahead. -4x plus 2, he says. Do we all agree? Me too! Starting at 2, and I have a slope of -4. Perfect. Now, the last one. Although it doesn't actually touch my y-axis, I know where it would touch, right? If I just went, because the slope is just a -1, right? Yeah, so -x. So I can just go up 1 and back 1 and know that I would hit at 3. Now, what's going to happen if you don't know exactly where the y-intercept is? What if it doesn't cross perfectly at a number and it's somewhere in between? Are you just going to guesstimate? No! Don't forget that you can write the equation of a line with a point and a slope. So as long as you have any point, yeah, you can use point slope form and then just rewrite it into slope intercept. So, gosh, I wonder if we will hit another problem that has that situation. I don't know. Let's take a look at the second one. Do me a favor and just come up with your boundaries. Give me where each branch is existing. So don't do the equations just yet. Yep. So this one, hi. Thanks.
Thank you.
Evelyn, special delivery for you. These ones here on the ends, right? They're good, just going to keep going. So you keep going and you keep going. So that means I really only have changes. I have one right here at -2, and I have another one at +3. So I don't even have to bother with -4. Okay, does everybody have their intervals set up? Are these them? Do you agree? And double check if you have should have the bar underneath it or not, right? So for that first one, that's just a constant all the way to the left. That's only existing when x is less than or equal to -2. Yep, so I want the bar underneath. This one's going to be between -2 and +3, but I'm open on -2, so I don't have the bar. Closed on 3, so I do have the bar. And then this last one only exists when x is greater than 3. Okay, perfect. So there's our boundaries. Now I just need equations for each of these 3. So this one that's just horizontal, it would just be what's my equation for that guy? What is it? Just 3, right? Yeah. This guy, oh, we got lucky again. I do know it's crossing the y-intercept. I have it. It's +1. So then I just need the slope. Oh. Oh, yeah. -2/3, right? Because I know that that's a good point. If you tried to go from here, you don't know where that one is, so you're kind of lost. But we have a good point right there. So from one good point to another good point, -2/3 is right. Whew! What the heck is up today? +1. Now, my last graph, you could try and figure out where it crosses the y-axis. That would be fine. But I have a point and I have a slope. So I could just use point-slope form and rewrite it. So the point I have is at 3, 3. And what's the slope of this thing? 2, right? I'm going up 2/1. So if I just pop that into point-slope form and then rewrite it, do you remember point-slope form? I hope so. Y minus y1 equals m times x minus x1. And then I could just rewrite it very easily. 2x minus 6, and then add that 3 over. What do you think? We're all right? Everybody's good? Okay, okay. Why don't you try this one without me telling you anything? Get all the pieces. can't stop today. I don't know. Jeez. Could be allergic to Piecewise. Ah! Oh no. Just made it worse. Okay. You got answers? Who can tell me the first one? Go ahead, Mike. One half x?
Yeah.
Almost. What's your y-intercept? Yes! So 1/2 x plus 2. And where does it exist?
X is less than or equal to 2.
Perfect. We're agreed? Okay, Greg, what's the second one?
2x plus
2x plus 2. And where does it exist? With bars underneath or no? No, because they're open on both ends, so make sure you do not have bars underneath both of those. Good. And Bridget, the last one.
Negative x plus 4.
And it exists where?
X is greater than
Perfect. Did you say greater than 1 or greater than or equal to? Oh, phew. Okay. Yes, so we should have that bar underneath that one. Easy enough? All right, one more. Try it. Same thing. Get all the parts. Oops. Okay. The first one would be Mike, go ahead.
Well, -1 is less than x, or is less than or equal to 1.
So you're not wrong. You just did my middle one.
No.
Yes. So everything he said was right for the middle one. What's this guy? Go ahead. -2, and he exists from? Yeah, when x is less than -1, right? And then this guy, his equation is? Well, he exists when x is greater than 1, and his equation is 3x minus 4. Yeah, so double check that you have what I have. Okay. So, not so bad? Alright, so I do have some practice for you to try. Oh, actually, on the homework from last night, can you go ahead and do number 3? Okay, so this one's a little bit different, maybe, or maybe not. I don't know. So first, let's just make sure that we all have the same equations, because those should match up spot on. So, did you get, for the first one, negative 2x minus 14? So this one, that was a great example where I just picked a nice point on the line and used the slope. And then popped it into point slope form because I wasn't counting. I didn't know where it was happening. It's too much work. Pick a point and pop in the slope. Point slope form. And then when you rewrite it, you get the y equals negative 2x minus 14. So I had that one. The one in the middle is great because I know exactly what the y-intercept is and the slope is just 1/3. So we got that for the second one. And then the third, just going to be x minus 9. Again, you could do point slope form. This one's not that bad to count back and get to negative 9. So, do we agree on those three? Now, what we might disagree on are the boundaries. They should be happening at negative 3 and positive 3, but who's the or equal to's and who's not? Right? So here's what's interesting about these. You have these two branches, let's just look at these two. They both hit at the same spot. Can they both be closed? No, someone's got to be open and someone's got to be closed. Right? So it doesn't matter who you pick to be open and who you pick to be closed. It doesn't matter. I don't want to have any overlap though. So I don't want to make them both equal. Because then if I go to plug in negative 3, where am I putting it? It technically won't matter because I'm going to spit out the same answer. But if I pick that one to be open, I'm just going to make that one closed. Or vice versa. If you had this one closed, then you just make that one be open. And then the same thing happens over here where these two meet. Someone's going to be open, someone's going to be closed. What I definitely can't have is both of them to be open. Then there would be no value there. But I do have values there because they're closed. So, remember the other day we talked about how in my boundaries here, I don't want to have any overlaps. So, when I want to plug in a value, I should only have one of these where it works. Right? So just double check that on yours. So these, you might have the bars in different places than I do. And that's okay. But I shouldn't have, if you plug in negative 3, it should only go in either the top, the middle, or the bottom. When you plug in positive 3, it should only go in one of these three, not multiple. Does that make sense? So you just look on yours. There's not one right answer for that when you have an overlap, because who knows which one it was. Okay, does this make sense? Everybody's good? Yeah? Wow, all right. Okay, so let's stop this here.